Hello everybody, we're getting ready to do lesson 9.3 of pre-calculus math today. And for today's classwork lesson we have hyperbolas and rotation of conics. Part 1, we got 14 points here on your notebook sheet, and you got 32 points here on your classwork sheet. So get prepared for that. Have your classwork sheet out in front of you. And teachers and students will start today with today's bell work. Graph these functions, students. So graph these functions on this grid here for 115. Then 116, here's your grid here for your graph there, students. Teachers, give your students about 5 minutes. See you in 5 minutes. Okay, welcome back everybody for today's solutions on today's bell work. For 115, h of t equals the negative of quantity t minus 2 quantity cubed plus 3. And for 115, this is what your graph should look like here for this function here. And then down here, h of t equals 1/2 times quantity t plus 4 quantity cubed. And for that cubic function, this is what you should have here, students. You should have that. And today's lesson, page 1 of today's lesson, introduction. So the definition of a hyperbola is similar to that of an ellipse. The difference is that for an ellipse, the sum of the distances between the foci and a point on the ellipse is constant. Whereas for a hyperbola, the difference of the distances between the foci and a point on the hyperbola is a constant. So the definition of a hyperbola is a set of all points x, y in a plane, the difference of whose distances from two distinct fixed points, the foci, is a positive constant. So this is your definition here. Students, this should go into your notebook or your notebook guide. That out. Then here's an example here of a focus. We have focus here, and then here is our focus. Our one focus here, here's our second focus here, and then the distance 2 and then the distance 1, d2 minus d1 would be a positive constant for all of the points on your hyperbola. So the graph of a hyperbola has two disconnected points called the branches. So we have branches here, and then a branch over here. Here's a branch here, and then here's your second branch here. So the graph of a hyperbola has two disconnected parts called the branches. So these are called your branches of your hyperbola. Here's your A distance, and then here is your C distance here. The line through the two foci intersects the hyperbola at 2 points called the vertices. So here's your vertex 1, vertex 2. The line segment connecting the vertices is the transverse axes. Here's your transverse axes here. And the midpoint of the transverse axes is the center of your hyperbola. So this would be the center here of your hyperbola. Okay, slide number 3. The development of the standard form of the equation of a hyperbola is similar to that of an ellipse. Note, however, that A, B, and C are related differently for hyperbolas than for ellipses. For a hyperbola, the distance between the foci and the center is greater than the distance between the vertices and the center. So the standard equation of a hyperbola, this goes in your notebook, students, so we'll be taking these notes. The standard form of the equation of a hyperbola with center at hk is, here it is, x minus h quantity squared over a squared. minus y minus k quantity squared over b squared equals 1. So this will be when your transverse axis is horizontal. Here is your a squared, which is underneath your x minus h. So this will be your transverse axis will be horizontal. And then for vertical transverse axes, it would be underneath your y minus k quantity squared would be your a squared for a vertical transverse axis. The vertices are a units from the center, so a units from the center, and the foci are c units from the center. Moreover, c squared equals a squared plus b squared. If the center of the hyperbola is at the origin 0, 0, then the equation takes one of the following forms. We either have x squared over a squared minus y squared over b squared equals 1. And you know this transverse axis is horizontal because your x squared is in the numerator of your a squared here. Or the horizontal and vertical orientations for a hyperbola continued. So in this situation here, we have x minus h squared over quantity h squared over a squared would be this one here. Here is a horizontal axis here. Our a squared is underneath our x minus h squared, so our transverse axes would be horizontal. And so then their y minus k quantity squared over b squared equals 1. That would be the remainder of that standard form of an equation of a hyperbola. And then the transverse axis in this case is horizontal. Here it would be vertical. And when you have this situation here, your a squared is going to be in the denominator of your y minus k quantity squared in this situation here. Page 5. Page 6 now, we go into an example. So finding the standard equation of a hyperbola. Find the standard form of the equation of the hyperbola with foci of -1, 2, and 5, and 2. Vertices will be at 0, 2, and then 4, 2. So with a situation like that, by the midpoint formula, the center of the hyperbola occurs at point 2, 2. Since we know that our foci are here are -1, 2, 5, and 2. And then our vertices are 0, 2. The center of the hyperbola occurs at point 2, 2. So that would be halfway between our 0, 2 and our 4, 2. Furthermore, c equals 3 after using our formula there for finding c. And then a would equal 2. It follows that b would equal radical c squared minus a squared. And then we plug in our values here, 3 squared minus 2 squared. If our c equals 3 and a equals 2, that comes out to radical 9 minus 4 would be radical 5. So furthermore, our b here would equal radical 5 for this one. And this is just doing it analytically without a diagram. So the hyperbola has a horizontal transverse axis, and the standard form of the equation of the hyperbola would be this now. Plugging in our values, we get x minus 2 quantity squared over 2 squared minus y minus 2 quantity squared over radical 5 squared would equal 1. So that would be our plug in there. Then when we simplify that, we get this arrangement here for this hyperbola here. So that would be our equation for this hyperbola here. Okay, let's try one now. Find the standard form of the equation of the hyperbola with the given characteristics. So we have vertices here at 4, 1 and 4, 9, and then foci here at 4, 0 and 4, 10. So I got this divided up, the guided practice, and then your independent practice is down here. I'll start the solving of this, and then students, I want you to finish that out on your own, on your independent practice. So we know our vertices are here, 4, 1, and 4, 9 here. And then our A in this case will equal 4. And then our foci now are 4, 0, and 4, 10. Our C in this case will equal 5. And then now we use our B squared equals C squared minus A squared equals 25 minus 16 equals 9 would be our B squared. So we know our A, B, and C for that. So knowing your A, B, and C and plugging that in to the standard form of the equation of a hyperbola, go ahead, students, and find your standard form now that you know your values for your A, B, and C, and put that down here. Moving along, asymptotes of a hyperbola. Each hyperbola has two asymptotes that intersect at the center of the hyperbola. The asymptotes pass through the corners of a rectangle of dimensions 2a by 2b with its center at hk. So this would be an example here of sketching asymptotes for this hyperbola here. So our hk plus b, and then this dimension here would be your h minus a over k. So this would be our 2a, and then our 2b would be this dimension here. And then once you have that, then you can draw your rectangle and then sketch your asymptotes through the corners of the rectangle to provide the asymptotes for your hyperbola. Asymptotes of a hyperbola: y equals k plus or minus b over a times x minus h. Asymptotes for the horizontal transverse axes. So the horizontal transverse axes would be here. So that would be your y. That would be this one here. And then y equals k plus or minus a over b x minus h. Be asymptotes for the vertical transverse axes. B minus a. So we flip this fraction here to come up with our calculation here for our vertical transverse axes. So this would be our vertical transverse axes here for that. In case we had a hyperbola that was like this, you would use this formula here to find your asymptotes for that. In this case here, we have a horizontal transverse axis, so we would use this formula here as our way of finding the equation for these asymptotes. The conjugate axis of a hyperbola is a line segment of length 2b joining h and then k plus b. When hk minus b, when the transverse axis is horizontal, the line segment of length 2b joining h plus bk, h plus bk, where would be right h plus a, so your h would be h plus bk, and then h minus bk. So that would be this here. So that would be for joining when the transverse axis is vertical. So that would be this line here. So knowing that, sketching a hyperbola. Sketch the hyperbola whose equation is 4x squared minus y squared equals 16. So write the original, would be your first step, and then divide each side by 16. Want this equal to be 1 out here. And once we do that, we end up with this here, x squared over 2 squared minus y squared over 4 squared equals 1. So this would be, we factor this 4 out, this would be a 4 down here, that would be 2 squared, and then this would be 4 squared here. So writing that in standard form. once we are to that point. Because the x squared term is positive, you can conclude that the transverse axis is horizontal. So the vertices occur at -2, 0, and 2, 0. The endpoints of the conjugate axes occur at 0, -4. Using our conjugate axis formula and 0, 4, you can sketch the rectangle shown here. So here's our rectangle here to sketch your asymptotes. Right here at 0, 4. See, when x equals 0, y equals 4, we have that there. And then 0, -4 would be down here. We have that. So we draw a horizontal line here. Then we have -2, 0, and then 2, 0 out here. So we have our two vertical lines of our rectangle that we can sketch our asymptotes. So y equals 2x and y equals -2x. So this would be your y equals 2x. And then this would be our y equals -2x here. And then through the corners of this rectangle, you can complete the sketch as shown. So here are asymptotes for this hyperbola now. And then we go ahead and we just sketch in our hyperbola. And that should be how it looks like here. So x squared over 2 squared minus y squared over 4 squared equals 1 for that case. We also get this here when our 4 squared, our largest amount here is underneath our y squared. We know that case it's going to have a vertical axis there, major axis for that. So graphical solution for that, solve the equation of the hyperbola for y. So plus or minus radical 4x squared minus 16 equals y. So we have that situation, then use a graphing utility to graph. We solve it for y, and then we plug that into our graphing calculator. We come up with plus or minus, and then we can throw that into our calculator, and then you should come up with this on your calculator's screen for graphing this hyperbola. Okay, let's try one. Students, find the standard form of the equation of our hyperbola here. So let's find that. And then B, find the center, vertices, foci, and asymptote. So here's A here. We're going to do this as our guided. B is on you, students, to go in and do that on your own. Find the center, vertices, foci, and asymptotes of the hyperbola. And C, sketch the hyperbola. So this is where you would sketch your hyperbola. I'm going to do the A, and then you're going to do the B and C in class. So for the A here, find the center, find the standard form of the equation of this hyperbola here. So for that, this would be it here. We're going to get this equal to 1 over here, divide through by 36. We end up with this here. So here's your standard form of that hyperbola. So you're good on that. The rest of this is on you, students. I want you to do that on your own. And that's 9.3 part 1. And if you need classwork sheets, homework sheets, notebook guides, classwork guides, etc., solution PowerPoints, email me at animatedpowerpointmathvideo@aol.com. Thank you very much.